Good morning. Good morning, everybody. Namaskar. Senior Suraj Singh speaking from Bharat, India on this day, June 3, 2021, and in relation to daily talk, whatever talk about engineering and otherwise, title of today's talk is same civil field engineering, COVID-19 impact on engineering, designs, construction, methods, contracts, organizations, communication, coordination, quality and excel. Why be behind quality always? Why to think about quality always? It is because of capacity of being competent in terms of chartered engineer, in description of chartered engineer, and in, you can say, consistency, competency, you can say capability, you can say whatever you can say, elevation, and you can say also membership of statutory body, that is Institution of Engineers India, being fellow of that FIE, and also talking about quality, which is life. You cannot make your life if you don't have quality. It's also very important. If you want to have good life, or if you want a good product life, good your life, product life be good, your life be good, society life be good, nation's life be good, and you live with confidence in quality, means confidence in product. You have confidence in yourself, means confidence in your capability, confidence in your performance, confidence in taking decision and doing job. Decision making, process of decision making, and requirement of decision making, same way, making decision and then thinking to apply that, arranging for its application, whatever applications are required, whatever procedures are required, to that in a professional way, in a becoming way, with quality attainment into that product or that article or that service, whatever. Application must be there, and that is called engineering. Without application, there cannot be any engineering. Engineering is application of scientific principles, and science is, you can say, basically and primarily to understand how universe works, how nature works. Science is not subject of origin, it is subject to study origin. It is subject to understand procedures. It is subject how universe has been devised, how it has been working. That is more important. And science tells us how something is happening, how systems available in nature have been working, they are working. This is only result of science, that we understand nature. It may be empirical, or it may be devised or derived, or logical calculation, or understanding, or you can say definition that we give, and we discover through science what is actually happening or what should happen with evidence or proven formula. That is called science. In simple way, we can say science is a word where we understand nature of living beings and nature of universe physique. Science then leads to word of engineering, which are connected one. Science tells, use this formula, use this derivation, use this principle, and apply to get some product. That is called engineering. In pure world of engineering, we say promotion of sciences, promotion of engineering sciences, promotion of engineering applications is is brilliant way to do a job. We say definition of engineering, actually that is definition understood or created by engineering itself, though there is no need of defining engineering because every work is engineering. To be very frank, if we use engineer as verb, it is something different. If you use engineering a profession, that's another word. When we say engineer something, it doesn't mean you should be an engineer. It means everybody does something based on certain procedure and principle or certain formula. That itself is engineering. People name social engineering, this engineering, that engineering. There is no engineering that bad. To do something is engineering, to do something based on thinking, based on derivation, based on empirical world. Again and again, repetitive applications of something logically defined or logically achieved or logically observed. That is, that process, that application is called engineering. It may be based on contemplation, it may be based on logic, but it is called application that results into another subproduct or product, or again it is to be applied to be final product. What I can say is my understanding, though I am here from field of civil engineering, and civil engineering is not a product like that we understand, but ultimately it's a product more powerful than other mechanical or other electrical or other products, because this is very much permanent, while other products may depreciate finally or become salvage after 5 to 10 years. It is engineering product that is not even salvaged in century. There's a difference. Engineering product is more powerful. For example, in civil engineering, product is building, product is flyover, product is road, product is railway track, product is dam, product is whatever you can say. There is no product, there is no development that can move without being part of civil engineering. So it's a matter of great pride that civil engineer has to think, civil engineer has to place himself or herself in that world of powerful domain where I think nature itself is involved. Again and again I have thought on this and I have commented on this, that there is no greater engineer than nature itself. This means there is no greater engineer than God itself. God, to whom I don't name, to whom I don't devise. God is that who comes in my imagination, who comes in a hypothetical world and tells me you have to do this. It doesn't tell directly. Sometimes it tells me directly also. When I make mistakes, for example, I am writing, I do some error, I don't find at that time, or I may not be able to discover that. I get some indication, and that indication is that something happens to my eyes or something happens to something which tells me check it. And when I check, I find there was some error, there was some missing. That's how that power works. That power never works to you directly, never talks to you directly, but indirectly through medium of signals. And that is what it said. Natural engineering, I can say, because it's linked to me. It forces me to point out, it forces me that there's an error, to correct that error, and really I find some error somewhere, or it says there is something happening around you, go and check it. And when I check it, I find something missing or something added to. That's what it says. So I have my experience in a different way. It is connected to soul, it is connected to mind, it is connected to material, and it is connected to formula, it is connected to sources, and then it is connected to engineering of materials, engineering of production, engineering of human being, and engineering of thinking. I say thinking itself is a part of engineering. It's an integrated part of engineering, because without thinking, nothing can happen. If I stop thinking, I am sure that is also not in my control. I can't stop thinking, even if okay, I'm not thinking, and again, in within a fraction of a second, I start thinking, and that is, you can say, not in my control. Thinking is not in my control. Yes, what to think is in my control. I can say, okay, I'm going to think about this. People may say, oh no, you cannot even think because God has to tell you, think like that. Okay, we can appreciate both way. Thinking or based on God's procedure of thinking, whatever it is, ultimately thinking. Sometime in my dreams I think, I don't realize that. Sometimes I do something in my dreams I never thought of, but I do. And sometimes I remember dreams. I am habitual of remembering dreams, and I have developed this as my quality. To some extent, I remember my dreams during sleep, and then I can say I can dream during eyes open or during when I'm not sleeping. When I don't sleep, that is also dream. So dreams are shown in dream world and dreams are shown in non-dream world. You may call them ambition, you may call your desire, or you may call your capability deserve. Capability, you deserve that. It's up to you. Everybody has got some dream, and we cannot say dreams never come true because dreams come true if you think, if you do. Some dreams are dependent on your efforts, and some dreams are dependent on God's efforts. Your efforts are more important because whatever God has to give you, God shall give you. God will never say don't get it. But whatever you have to achieve, that is your dream. Means you have to do everything. You should not leave any stone unturned to work for achieving that dream. Even if you do not achieve that, don't worry. Something you will achieve. That's main part. This talk is not for dreams, but this talk is for thinking based application, analysis based application, synthesis based application. Analysis, synthesis, and thinking all are related. Thinking applies before analysis as well as it applies post analysis, and thinking applies before synthesis and it applies post synthesis. Thinking applies before application and thinking applies after application. Both apply that way. And then when you think something, believe me, you move advance. Sitting and thinking moves you to some other locations where your mind goes and you find out something there. This is solution. You don't move there, you sit physically in chair or in bed, but your mind moves basically because of thinking, and this mind goes to miles away, thousands of miles away, and you can say you got some answer to your problem, and that's called brilliance. And when you understand even risks this time, this is risk in this case, and not only you understand that, but also you procure solutions, probable solutions to that problem, and when you try to apply that solution, you see, oh, I'm getting result out of this, and that was important. And I can say it is called mind engineering, mental engineering. Reliability exists in all engineering world. Reliability must exist everywhere. I can say whatever I do, whatever I produce, first of all, it should be safe for itself, and it should be safe for system, and it should be safe for everyone. And whatever I expect, whatever service I expect from that product or from that human or from that professional, I say that service should be tenable, that service should be applicable, you can say capable, that service should be useful, that service must function to what it was intended for, or maybe it was not intended for, but it provides. That service is extremely important word. It's a part of world, it's a word. And then how long can we use that product or that service? Service may not be used for long, but product may be used for long and long and long. That is point of product durability, which I call how long that product can move. That is defined as durability. And durability we define in concrete. Durability we define in our work, our structures. We say concrete should be durable. We say steel should be durable, and whatever we say, whatever product we use, it should be durable. But we do not define limit. We do not define what is limit of this being durable. And durable is, we fix, for example, concrete is durable for so many years, say 20 years, 30 years, 40 years, 50 years, 100 years. Same way we say steel is durable for so many years. That period is based on experience. That period is based on how in long run this material deteriorates or this material gets hysteresis, and you can say it loses its power to resist, or how much it can be impacted upon, destructive power of fire, how it can be impacted on gradual destruction due to moisture ingress. All these points are important to be considered and have to consider. Therefore, reliability varies from environment to environment consideration, and also from physical consideration of material, and also from components of materials, and also from combination of various materials. Durability can be classified differently. Of course, they say durability cannot be defined for product. For example, some product can be used only for 2 years, 3 years, or 5 years, or maximum 10 years, say. We can't say that there is a durability. Yes, you can say, yes, it's lifelong product. You may say 5 years lifelong or 10 years lifelong. That is not defined. But a life means entire life for them maybe 3 years. In general, products, they consider life is 3 years. But in products of construction, in products of civil engineering, 10 years is not that much stronger, except for, you can say, for world of roads. You may say that even bridges are not, even maybe not more than I think 40 years or 50 years. And roads, you can say every 10 years, 15 years, these are changed depending on what sort of road it is. You see how to keep them strengthened or do again and again. But products like sewer line, water line, they work for more than 25, 30 years. Products like RCC structures work for more than 50 years to 100 years. And also all other structural steel, for example, in industries or industries itself, where oil industry or some industry, they keep into their consideration a period of 30 years. So you can say durability duration varies from from class of project, class of product. So it is called, means for that durability, if it works well, or it works for, you can say, after retrofitting, it is extended to 1.5 times or 1.25 times or double. It's also important with small investment or good investment, rather than producing new project. You can use that one, prolong life of that one. And it's also, so by this way you can say, you can fix risks. This is risk. If this happens in so many years, this is risk, and that is control we have to do. And that's we call, you either retrofit it or demolish or dismantle it and do again. So our these principles which I said, work of analysis, work of thinking, and work of synthesis, these are, I can say, works, because analysis is also a long procedure, depending on from small problem to major problems, and particularly when you find forces and members of a structure. These are very important. Of course, there are set principles, set formulas and theories, but we apply them. But after all, whatever theory is there, you have to understand that. You have to justify that. You have to recalculate that. And that is called analysis of forces. All forces, whatever forces, you know all that. Direct load, bending moment, shear force, deflection, sway, or seismic action, wind forces, thermal effect, whatever is there, upward direction, downward forces, whatever forces you consider in designs, that are our masterpieces of analysis. It's not simple analysis. Of course, it is called analysis. It's called structural theory. It's called designs. It's called structural arrangements. Because there are so many names can be given. I don't understand why structure was given. Nobody can explain that. You can say, okay, structure means various parts are connected together is called structure. So structure applies everywhere. It may apply in flights. You can say there's a structural casing of flight. We know that. How these layers, multi-layers are in walls of flight in plane, and how it moves, how it taxis, how it takes off, how lands. There are various structures of that. Various types of steel is used. Cryogenic steel is used when it's in say minus 60 to 70 degrees, and on ground when it's 50 degrees. Same structure. Steel is used. Means that steel is so much contained in this, so much resistant to minus 60 to plus 50 or minus 50 to plus 50 degrees. It can digest. You can see material of that one. How, what type of that material is, what are its components. Means to say this is structure applies everywhere. It's not that only in construction and civil engineering we do it. Structure is a structure. It is, you can say, our body has a structure. It has bone structure, it has other structures within this, and if these are not well up to date, we get sick. So structure applies everywhere. Structure of a building, structure of road, structure of railway base, structure of, you can say, manhole, structure of, you can say, hotel building, structure of atomic structure building. You go wherever you find whatever you say, some kind of structure exists, and that structure to be better, I have to make it further better. I have to improve it as much as we can do, and that improvement is very important. It brings into our mind how to make it better, how to make it cheaper or less expensive, and how to prolong its life, how to make its use better, how to get additional use out of this. These points we consider. But these are all based on basic principles of analysis and thinking. Thinking and analysis are very much related to each other and directly proportional, no variance. If you cannot think, you cannot analyze. And if you can analyze, you cannot think as well, because both are reverse process. Thinking starts, but once you think something, you say, yes, I have thought of this, and that thought, that process, that semi product you get, you got something and you say, I produced this, I have reached first thinking level, I got this answer. That answer is also sub product. Then you further use that answer to somewhere else, you will find another sub product or little senior one. So that way product goes from one stage to other stage, and ultimately it is finally shaped and delivered. Now what it is delivered, that depends upon quality of its production, quality what it has. That is important point. I have to come back to quality, because quality is ultimately our aim. Though quality is a word only, it's a term only, QULITY, but it is property of material that we induce in. Some properties are induced by nature, we cannot change them, we have to accept them. Some are induced into material by human being, by professional, by manufacturer, and whatever been processed. That quality is what we are talking about, because natural quality you cannot change, but you can use that material with other material combinations, and we may get many materials together to produce some common properties which are artificial properties we created in due to natural material already having some properties. So you can say natural material properties and artificial created based on artificial intelligence or based on use of mind, or based on natural reactivity of those materials or inertness of those materials, but in combination forming relations with others for permanent use. It is, you can say, that is called quality. It is expected to your requirement or basic requirement, or it's better than that, that's welcome. But it's not better than, it's just worse than it's expected. That is not called quality. That is called you did not produce material with required quality, with intended quality, and because you failed to do that, this product cannot be accepted, or we keep in substandard class, substandard use. That happens. you know, you understand that quality is such a subject I should say rather than, because it's major subject. Though there is no syllabus for this, but it's subject that that's, that relates to that relates to all syllabuses, and that's where quality lies in. Quality has taken long journey to develop. I cannot say that it started at one day, first one day. On that day it started and it moved to second day and then third day. It's not like that. It happens because of experience of products. It happens because of use of product. It happens because we set something. Okay, we do not want this standard. We want that standard, better standard. So we reject good standard and want better standards. And then there is better standard. We have best standard. Like that, we can say no. We want much more better than what is already best. So that way, quality moves on. Means it doesn't mean in initial first stage whatever was done was quality less. That was also quality full quality. But but because use was decried, it was not accepted, so it goes obsolete. Then we say okay, we change it to new system, and we say okay, this is currently quality, this is current quality in our state or our country, and we follow this. But after some time, so now we have to augment this level, and we give give a single okay, this is obsolete, we follow this now, this updated one. That's what quality means. Every stage has quality. You cannot say when it was not properly understood that was also quality, that was quality. Now you are making another one, that too is quality. Time to time, quality to quality, change to change. This is basics. So quality, engineers have to understand in a different way. Don't confine yourself to what you are doing. Don't confine yourself. Yeah, I'm in structures, I'm in construction, I'm in planning. Don't stop there, because your quality is voluminous. Quality of engineers cannot be confined to one topic or one subject, because if you confine to that, you will be isolated from total world of engineering. Yes, you can specialize indeed, but you have to be related to others. You have relations to all subjects of engineering, all acts of engineering. Yes, we designate ourselves civil engineers, mechanical engineers, other engineers, whatever, sub engineers, sub-discipline engineers, discipline engineers, but that's only for sake of job, not for engineering. In engineering, it is totality that works. If somebody says you have to engineer this means you have to do, you take responsibility of this for final touch-up project, final project. That's called engineering. To start from scratch and go to final delivery, that is engineering. And you can say think and do it, just like we say in management or in controls. We say plan, or you can think first, think, plan, do and deliver, and check. Plan, do, first of all plan it, do it, check it and review it, right? So there is a procedure, you can name in whatever terminology, doesn't matter, but this is guaranteed that some system is created, by individual or individuals, based on capacity, based on consistency and competency, or you can say based on learning. Whatever product we reach, whatever element we reach, it depends on our attitude of working, our attitude of thinking, and our attitude of honesty, sincerity, punctuality, regularity, and dedication. And whatever we committed, we want to keep our words. It's not question of my mustache, it's question of product result, it's question of production. Commitment. It's not commitment that I'll get my neck cut if I don't do it. No, not that. That is not this one. Here is just to do something, produce something, understand it, review it, apply it, improve it, and then again say it's better one than last. It's better one now if you compare to last one, and you can say whatever parameters we do have, we have to apply on that. We have to apply. If there's no way we can't apply. Application is terminology that is used for engineering, and without application there can be no engineering. It may be design work, it may be execution work or prosecution work, or it may be field work or whatever else. Everywhere you can say we have to include all parameters which may not be useful or may be useful or may be considerate only. So that's what I say. It's different quality, I say, is required, and it's required everywhere, in whatever form it is to be done. You may call it quality, you may call it standard, may call it industrial practice, or you may call it my approach. Sometimes there is no quality definition for some activity, so it's called, even though there may be some industrial system, but people don't know. So I did it, I defined this, and that is called how to do that. And that system is known as writing something into some title of document, and that title is writing is method, statement, or procedure, which is dominating standard, because that standard is charted by you between agreement you reach with contractor, you reach with yourself, or you reach with someone else, where all parties who are stakeholders currently on site or on project, they accept to do something in some defined way, which is also quality based, because many procedures, many qualities come into contact, converge at one point, and we write something that we are going to do this way. That's also a piece of, you can say, it is agreed quality, or it's agreed quality means it's not systemic work. We are making a system of how to work it. So it is executive or prosecution based quality, which depends on how it performs, and we will change it again if it's required, and that's called method statement, which is very much important here. Method statement, you can say construction method statement, which is a must, and if you do not do this, you cannot understand quality. You cannot, and you become a slave of small knowledge. You become a slave of what is written by someone else. You become slaves of those who never experience work, who just want to be their name in writing that I did it or he did it, but actually they did nothing. So method tells you, method is to be complied with. Once you chart out method, you chart out, you can say method means procedure from A to Z will chart out for some work, and that if it's successful or successful with certain restrictions or such qualifications, and you can say, okay, this point we took wrong, we change it, and there's a change in that line within certain document. That line is to be incorporated in future within revised document, because whatever you replace that with, that's also part of method statement. Method statement, simple terminology, but it's very valuable terminology. I've not even heard people use method statements in our country. Maybe they use something else. They say, no, I'm experienced, I can do this. Means here we don't believe in documents, to be very frank. We think codes are Bibles, or we think that whatever others have written, they are Bibles, or we think those professors are only authorized to write something. We have such misconception in our mind, because writing is slave to none. Writing is slave to none. Everybody has a right to write. You can write only when you can think. You cannot write essays or poetries or stories. It is an engineering world. It's production world. It is, you can say, world which makes world. It's a world that develops world. So it's a very different in engineering to do something, to convert some procedure into writing without understanding, real meaning of that. Once you start writing, you may write one part, then second part may be thoughtful again. And of course, what happens if you do one project, you can convert that. If you say, oh, I have done this successful, our people have done this successfully, this activity, and you don't have any method to that, and you can make sure there's nothing wrong in this act, in this matter we did, and you can bring it to paper form, and that also becomes one of you can say practice, one of work method or work procedure, and that can be included for work in future, because everything is not given in books, everything is not given in codes, everything is not given everywhere. It is sometimes we have to assume or we have to adopt based on success of something. And success if we get, that's very important one, because success only gives us a route to solve problems. It's really important. So I would say, as I say, in organizing something, you have very important points that we have to cover. We have to first of all take time of work, how much time it will take, what time you have to start, what time you have to end, and also we have to consider cost of that, because without cost nothing is expected. Cost must, cost is you can say cost is a criteria that you have provided, you have devised for some work, and that cost should be maintained. It should not escalate. If it escalates, it can disturb, it can impact on budget of your project, and if budget is impacted, means extra expenses are made, then you cannot complete that project. That is also true. So time and cost are important factor, and then quality is one factor, that even if you don't understand quality, whatever results do come after doing something, that is also a kind of quality which is undefined but achieved. You achieved that, but you could not define that. Now you may define it in different terminology, and that can be part of your work. You created quality, you can say, you created your way, and then later on, if it's successful, it can be covered into methods. So it is very important part. The methodology or methods production is engineering production. Methods do not come single-handed. This comes after conducting deliberations with contractor, deliberation with the engineer, deliberation with a specialist, and deliberation with whoever does it. You can know pros and cons of that, merits and demerits of that, only after conducting, after doing interactions with those involved. That. So when I say that every time you have to understand differently what is your method, what is your procedure, how best you can do it, because it's question of materials, it's question of resources, it's question of designs and drawings, it's questions of what sort of workers you have or you can arrange. It depends on what you think, how to do this activity, what are temporary works there, what are permanent works there, what are preparatory works there, what are other sources, what manufacturer states about that of some material, or what you think it's more better to do that, what are protective measurements. Means there are so many points that can be considered in every method statement, and we have to be, we can say, very clear in this aspect. You should not even say, oh, what is method statement, I have never done it. You always do, only problem is you don't record for reference. You don't record and you think, why waste time in this? Those who think the method statement wastes time, I think they can never become engineers, because they are nothing waste of time while you are doing some writing. And this writing may be, if it is common, it's not very specific, it shall be used many number of times, because you have to do formality as well as you have to communicate in reality. All stages are there. So my dear friends, I don't want to talk much more every day on quality, but because it's demand of time, I am really surprised these days. I have been surprised. I am surprised to see that quality does not exist in our profession now. I don't know reason behind that. Reason being that we don't have very much educated or high caliber engineers. I can simply say there is no doubt. Every people are not interested in quality. People are only interested either in execution or in designs. A person who is in designs, he thinks of designs only. He doesn't think, of construction. But thus, this person forgets that design is meaningful only when it is successfully done. It's carried out. And if it's not done successfully, your design is only in books, it's only on papers, it has not been tested. And that test comes from successful implementation of design on whatever structures they have or you produce. And that is very important, that structures cannot be discarded. We cannot do that. If you do that, you suffer. Therefore, quality is very much different. Quality has very many meanings which you have to understand. I, whenever I speak of quality, I don't know how it comes to my mind, what to speak. I'm thankful to God that something comes to my mind and it empowers my improvising. I question myself, I answer myself. And it's very, very important work of use of mind. I think it's good quality to think yourself, to question yourself, to answer yourself, and then thoroughly study your answer. Means another stage comes in, then another improved answers comes in, and then another stage comes in. Like that, you have to go to first thinking, its entire completion of method, second thinking, then its consequences, third thinking, then its consequences. Like that, you can move on and ultimately find some best solution, and that's required. Quality solution, you can say. It's not only solution, quality solution. And this solution tells you you are going to do this and others follow. So that quality is, you can say, achieved with establishment of its structure. And I can say that's also structure. Method statement is also a part of structure, because without understanding it, we have to understand first, then only you can write. And without writing it and communicating it to those who can't write, they have to understand in your language. You can write in two languages if one language, English, is not understood by someone. It's very important. So we can say there are so many factors involved in quality. Quality approach is one part, and there are many other approaches that we have to depend upon. We have to find out. We have to initiate. And job of engineer is complex. Engineers should understand. Engineer's job is not easy as we think, as these certificates are not easy to achieve. These are difficult certificates. These certificates are achieved only after long struggle of education, academics. Only then we receive them. Same way, every work is a certificate, I can say. I consider every work done is a certificate. It's not degree certificate, it's not diploma certificates, it's above that. It is product certificate. And if you say no, this is quality based one, it's real certificate because you have done engineering on this. That product, that project you deliver is actually engineered product. So it is engineering. It's engineering product means it's engineering business. So you are doing engineering that way. I produce this and it's done. That's why I always suggest to everybody, don't confine yourself to some discipline. Keep your vistas flexible, open, and move on and on until you can do in your life. Engineering cannot limit you, and you too cannot limit engineering. Yes, when people are young, they have ambitions, they have goals, but in civil engineering, there doesn't exist any goal. If you find an opportunity, you have to find to do job on that. You have to find your goals there, at least for that project. And if you do not get any benefit from that project for learning, then time will teach you, don't worry. So it's very important here. I explained to you something about quality. I cannot say what I explained to you is right or not right. It depends. But you can say quality is quality. Maybe you people say wasting time. We every day waste time. We every day waste time. But you know, it is no wastage of time, but it is correction of future wastage of time. It's that way. Yes, you may take few minutes today or few hours today to write some statement, or not to write but to just teach. Some people write a statement, some people don't write a statement. But what's right you think of? Means when drawings come, they tell something. They keep on record for months and then we start doing them. These drawings tell us. This is, yeah, it's also a method, Whatever drawing you have, architectural drawing, structural drawing, services drawings, these are also graphical methods. These are also geometry. It's written in form of geometry. What you are going to do, and that's what is important. Means you have to do this. That's what the drawing says. It says in text form as well as in geometry form, and that's also a method. You cannot say it's not method. Yeah, just plan, it's elevation, sections, but it clearly tells you how to do that. And then based on that, you clearly write what I have to do for it. So it is communication. It's drawing, or it is specifications, or it's something else, or even method statement. All are drawings in my mind, because they tell me what I have to do, and by method statement I tell others what I have to do. Drawing tells everyone what I have to do, and people do. Well, people think engineering is only drawing. No, engineering is a part. Drawing is a part of engineering, and engineering is part of development. So drawing is that document which tells you something. You have to do this, and you have to do in defined way. If there is a defined on drawing, it's defined on drawing. Okay, fine. Otherwise, it's practical one, or it's conventional one, or else it is specific one. Then you have to find your methodology, your method statement, your method points. It should be simple, pointed. It should not be that much explanatory that people waste time in just understanding explanations, because sight people are generally experienced for years together, and if sight engineer knows what is right, what is wrong, what to do, what not to do, that will suffice, I think. That will suffice, and that will be done. So it's not simple that we do work. We have to do work within certain standards. But standards are very important, and of course, you can say I involve myself to share with you certain quality statements. Quality statements means certain procedures which we have to adopt. Stage by stage procedures we have to adopt to achieve standard system or quality system on our activities. I had reached to some point on, you can say, generators, foundations, generator and alternator foundations. I had reached to that point, and before that I had to talk of pedestal footings, or you can say some footings. Then I had also to discuss with you RCC, suspended slab works, which are very important from every viewpoint, and we cannot just miss it. These are very important ones. Pedestal footings for structural steel, and also RCC works for DC generators and alternators, which we had taken in components form, and these components were RCC raft or alternator foundations in thick concrete column forms, isolation between generator foundations and raft. This we will discuss in some schematic forms, in some sketch forms, and I think that's I'll try to project to you now. These are, you can say, and also let me say I'll try to dig out all whatever I have. I think it's the same, so I have to put it off. I say same. I'll find another one. I think it is not same exactly. I'll find another one. Maybe I have to go back to my record. Let's say it. Sketch, maybe sketches, it should be sketches, generator. Generator alternator foundation lamina. I think same. So let me see what is that. Let me go to sketches. Generator foundation. Yes. First you see this sketch, which is of much importance. This is, I discussed before also, but now I just detail it further into specific form, and that is, with some more details. I just these are two sketches. I am going to deliberate with you, and this is really very important here for this item, which is checklist for RCC works for DC generator and alternative foundation works, for which I can say this is a sketch. I can say you can just see this. It's very important. There are two sketches of different dimensions, different strength here, and we will discuss these two in this talk. Meanwhile, let's go for a moment. So we have to take now this discussion to another height, and it is that I'm showing you this, this foundation that I'm showing to you. It's written massive block here, and this is limit of foundation. This is border of foundation. This is that one here, you can see. This is raft. This is raft. Generally it depends on design, what size it is, and that design depends on size of machine, and that is generator here, diesel generator, usually maybe 2500 kVA, 3500 kVA, and like that. Big generators I'm talking, a group of which generators, combination of which many generators can produce a standby power station. This is standby power station. It's not thermal power station, or it's not against hydro power station. It's different type of artificial power stations where we can combine many generators, big generators, prime generators, to produce electrical energy. And of course this is not like nuclear energy or solar energy. This is old system, but we have to understand machine foundation point is that this size depends on size of machine, and also how much area you have to leave around that machine, so that you can find this dimension. This dimension, that's called length and breadth of this raft. Thickness of this rafts depend on bearing capacity of that soil and your calculations. And you can say this is not like cantilever foundation, but this is raft foundation. Total load and impacts of that machine, vibration, all are considered, and you can design raft accordingly. Raft design is one part, because there are two elements in this. One is generator, other one is conversion of this generated current to electrical current to alternator. This is one machine, like there are so many machines. And also you'll find radiators attached with this, radiators, and then there is a storage fuel tanks also here. There you'll find raft foundation. And these two machines, generators, alternator, are located or stationed in some industrial shed, covered one. Fuel tanks are outside, radiators are outside, and this is very small project, you can say, but it is standby one, powerful, means very small. If you say 3500 kVA for one generator, so it's about 14,000 for 4 generators. So you got this 14,000 kVA. Like that, so many you can establish in your state. If it's not diesel generator, something else. This is just for learning. I'm saying how to do work on site. It doesn't relate to any design. This dimension also indicative one. And what are 3 points herein? One is this foundation raft I explained to you, and there's then a massive concrete block on this raft, which is here, you see in section. This is massive block, which is not connected to raft. It has no monolithic action with raft. It is not at all connected with concrete, because there exists one more element here in this, and that is this, you can see, thick line, which is an isolation mechanism, vibration isolation mechanism. It lies here, on which is rest this massive block. And this is another element of foundation, that is for alternator one. So there are 3 elements in this structure. One is raft, one is massive block, and one is alternative, and this is plan of this alternative, this is raft, and this is machine foundations, and there's isolation as I told you. Now you can see these grooves, these squares, which are actually these grooves, voids in concrete. Calculated depth here, I not mentioned that depth. What happens actually, we have to combine, we have to rest machine on this foundation. We have to rest this machine permanently on this foundation, and there are only two ways. One way is to directly place plate of machine bolts, base of machine bolt on this formwork area while concreting this, or that's not really appreciable because accuracy is a question there, correct location is a question there, and in heavy concrete members it's very difficult. So what second method is that we leave groups in these forms. All these are all small formworks, these timber or steel grooves fabrication is done according to this shape. These are all voids inside, means there's nothing inside. This is some sloping portion here, and this is vertical portion, but trapezium here, like truncated here. And when concrete is done, everything is over, you have to place or fix bolt system on these. There's a complete plate or various plates which you have to insert in these voids or in these grooves, you can say grooves. We install those plates, and then after right installation, these holes, these voids, these grooves are to be grouted by you can say epoxy mortar or equivalent material for grouting, or you can say other type of material which could be, if not epoxy mortar, it could be cementitious mortar, cementitious grout. And not only this portion, also space between machine plate, machine base and this concrete, because there are some supports below base. Those supports keep up above this, some millimeters above this foundation top, and space available between foundation top and base of that plate is grouted using epoxy mortar. Grouted. So you can say bolts remain inside, whatever bolts are there, they are embedded in your grouting. So there was no loss of strength due to these holes, and we can say that's done. Now that's one part. Other part is this. What actually is this? Isolation. Let's take this now. What is isolation? If you understand this, you can get this. This is, raft foundation, and on raft. And imagine, this is just imaginary, these lines, this indicate only massive block, and below that block you will find these plates. These plates are actually, you can say, steel plate mounted with neoprene pad. Neoprene, which is nothing but rubber, that is very strong rubber pad, and that is used for, it's placed on these steel plates. This steel plates are fixed to raft. That is procedure, and how these are fixed, that is here in this sketch. You can see this is sketch. This is plate here, plate here. This from here to here is plate, and this is neoprene or rubber pad on that. You can see these nails here. Nails are at this point, at this point, at this point, at this point. 4 nails that can penetrate into concrete. I mean to say, not a wrought iron nail, but nail manufactured of steel, because steel nail can penetrate concrete and it's easy. So these 4 nails, there are 4 small holes in these steel plates, and in this portion neoprene pads are glued to this or fixed very strongly so that these pads cannot come out. Pad doesn't come out. So what we do in this case, first we fix these plates on locations, and these are locations. All number of plates depends on design requirements. I've just given indicatively. This is not actual numbers. This is only indicative provision. So we first mark and place these plates, connect them by nails to concrete. That is one part. Then you see all raft. I am talking after raft is laid, raft has been finished. This portion, not whole raft I can say, this portion where plate, this portion where your framing shall be done, this portion where framing shall be done, that is an important part. And what I say here, these are these neoprene pads plate, and this is drying of framing actually. These are lifting hooks, you can say. These are lifting hooks, and this plan of frame, this is location of these neoprene pads. But I am talking of lifting hooks which are here. These are lifting hooks. So what we have to say, we have to fabricate one frame that's called steel frame, steel lamina. And if you see in this, you can see here, this is raft, this is steel plate. Here you see, this is steel plate, and above that, this is, I mean to say, here this is your double line, and this you can say steel framing and steel plate, and below steel plate there is isolation arrangement, isolation layers below steel plate, and above steel plate are these angles. You can see cross and both angles which are shown here in this way. These are your angles. You can see all these double lines. Means it depends on design. I'm just telling you indicatively. Only these are 40 mm by 40 mm or by 50 mm by 50 mm or as required per design. This framing is done. Here are hooks, steel hooks, so that crane, some you can say sling can be used. 2 slings can be used to here to here or here to here. You can see we lift here to here and hold it. And I have put about this length 1/5 here and 1/5 here and 1/5 here and 1/5 here. And if required, 2 more hooks can be placed in here. There's no harm. I did not place, it doesn't mean it cannot be placed. You can use 6 hooks rather in place of 2 and lift it safe. This is fabrication arrangement, and this fabrication arrangement keeping plate downwards, frame in the angles upwards. Once frame is held up by crane after it is completed, and your this isolation system is completed, which says if you start from bottom, it is here, you can say you start from bottom. Frankly speaking, We start from bottom. These are plates. You have fixed plates, right? You have fixed these plates here. All how many plates are there? Neoprene plates. You fixed concrete. Then in this portion, all where there are no plates, means all portion except this plate square, you have to lay neoprene. Not neoprene, polystyrene, heavy duty, which comes in rolls, and you have to provide all over this area, all over. And then you have placed two items. You have placed neoprene pads, which are concrete, which are connected by nails, and then this polystyrene, and on that you place rubber or neoprene sheet you place on that. This is system of isolation. All in one level. These plates are concealed now because of neoprene sheet, and if required, the isolation design requires something else. You can put also that there. Maybe you require polythene sheet. It depends upon your design of this sectional isolation. How do you want to move it? And once it is done, inspected, you can say you can transport or you can lift this fabrication item, this lamina which I showed here. This lamina is lifted. And placed exactly here as it is shown here. Exactly you can place here, and that's very important point. You place there, and where's that point? Let me see if I can find out. You can see in this portion, this lamina is fitted in, and this section is shown as we discussed. Isolation below fabricated lamina. So this is done here. Isolation below fabricated lamina. So layer is raft, then isolation. On that is fabricated lamina, and on that is generator massive block. These are components of this, and you can say this is important one to understand what we want to give. And this isolation is done that way, and then we have to, after we do this concrete, concrete means massive block, means I'm not told that one, but I'm just telling you procedure. Then you have to start, either you start this or you start that. Better we start this massive block and finish this. It's also a big job, very big job it is. And also you have to do this alternator foundation of concrete. There is already a cast raft and steel is available, and rings are complete, and make construction joint. Then you can do this. So this is sketches I tried to give you for quality purpose. But now let me read for you this item which is very much important, and this item that gives you clarity. I thought that I have given this on your text, but the explanation was important, and I get to that isolation is not easy. It is to be calculated because we don't want any vibratory impact from generator to foundation. We have to dampen that very much. Generally up to 50% of weight is considered vibration. 25 to 50%. Generally ordinary machines takes only 25% isolates. So no matter whatsoever it is, means it is question of design. And foundations, 3 foundations. One is raft, one is massive block, and one is alternator base. These foundations are in equilibrium, must be in equilibrium. We have to design that way, that machine that we're going to put on this, there should be two axes of that machine. One should be axis of loads. You may say, we can say axis means if you take it this way, there should be some axis on this wherever, and there should be another axis for this generator itself, machine itself, that we can say this operation, you can say operation axis, or you may say performance axis or operating axis. One is load axis, one is axis. So load axis, if you can say there are two ways, load may shift sometimes this way because of alternator and this foundation. Axis of rotation of machine is very important. Of course, this is axis of rotation. This cross axis also. It depends. Axis which should meet CG of this foundation. That is, machine foundation basis. That there should be, you can say, no resonance in this machine foundation. No resonance, which is very important point. We have all known that resonance should be avoided at any cost. This means whatever is frequency of operation and whatever is frequency of foundation, that is natural frequency of foundation soil system, we call it. Natural frequency of foundation soil system, and we call operating frequency of machine. This frequency should never be equal, because if these are equal, we know that resonance state is reached, and that can be very dangerous either for foundation soil system or for machine. So there's a factor is applied there, and we should keep the variance up to, you can say, twice. So that's purpose of machine foundation. You can use whatever method for design, Barak method or some other Barkan method or some other method. That's question of formula, it's question of solution. That's not purpose here. How it should be done, that's purpose here. So we can say theory is one part, but practical is another part. So in this we say, in this diesel, alternator diesel project, there is, generator foundation, generator alternator foundation, then there will be other oil tank foundations, and there will be foundations for radiators. Likewise, you can say so many such foundations occur. And it's not only foundations, there are many more criteria we have to understand. We will understand later stage in designs, but now we are talking of how to construct it. That is important part. How many components are there? You can say RCC raft, RCC alternator foundation in thick concrete column form, and isolation layers between generator, foundation or massive block and raft. These are major components of this design. I have gone through all this before, means I am just repeating so that you refresh. Ensure that waterproofing membrane or concrete soil protection work has been completed and protected. Ensure setting out on blinding is per design and approved. Ensure reinforcement of raft is correctly fabricated and placed within layout. Ensure proper concrete covers, spacers are fixed. Ensure cathodic protection is installed if so required, not necessary. Ensure concrete profile top levels are fixed. Ensure alternator foundation Reinforcing bars are placed in correct position. Ensure pouring concrete of raft, avoiding cold joints and avoiding and you can say in concrete profile top levels are fixed. Alternate foundation reinforcement bars are placed in correct position. Pouring concrete of raft, avoiding cold joints for procedures and carry out curing activities for defined period. Cold joints are never accepted. 300 by 300 or for design steel plates mounted neoprene pads are fixed to raft using 4 number steel manufactured concrete plates which nails must do proper fixing of plates to concrete. I still remember this instance when I was in Libya. I could not find concrete nails there. There's no chance, and we were not delivered because that time it was different country in 1983-84. So I could not find steel nails. So what we thought, after all, it's question of connectivity only. We could then we can say ensure pouring concrete of raft, avoid cold joints for procedures and carry out curing activities for defined period. Ensure that these plates of a designed steel plate 300 by 300 mounted. Neoprene pads are fixed to raft using 4 number nails. Manufactured concrete nails, which nails must do proper fixing of plates to concrete. After that, isolation. In isolation, we say check that polystyrene rolls are spread on areas of raft, but savings areas where neoprene pads are placed so that prefabrication lamina plate rests on polystyrene and above that neoprene. Provide a neoprene rubber sheet on whole system laid on raft. Place following details. Based fabricated plate on laid system. That plate I'm talking lamina, that is fabricated plate laid on system. Means isolation system which is laid on raft, that whole system. So reinforcing bars have same issue here. If you should use clean and rust free bars, free from rust, free from dust. And if you are going to use cathodic protection by providing, you can say, sacrificial anodes, you cannot use epoxy coated bars. And if you are using epoxy coated bars, then you cannot use cathodic protection. Both are reversible to each other. Generally, cathodic protection is provided, and we have to respect if it is provided. Then you have to check continuity, and also that continuity is very important. If there is some problem in continuity, you can squeeze your now. Touch-up paint is applied in case you have to use epoxy coated bars, though cathodic protection is not permissible in that case because there may be damages, there may be peeling off at hundreds of locations on bars. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars, and no cathodic protection is permitted on epoxy coated bars. Now we have to fabricate steel lamina isolation horizontal frame. It's not easy because this is technical, completely technical job, and you have to fabricate it. And this is very minor fabrication, of course, but very technical. Means it should be done according to designs, and that is check defined gauge of lamina or plate sheet per requirement of designs. Check sections of roll steel, that is RS, to be included for isolation frame fabrication. Ensure proper setting out of lines of rolled steel sections for on-site fabrication. Ensure proper tag lines markings for welding are done on plates for welding work. Ensure welding operation is rightly carried out on all markings. Ensure provisions of lifting hooks and ensure provisions of lifting hooks and their locations are correct per design. Ensure then you can say plate should be placed on laid system of raft such that lamina faces down and RS framing portion upwards to allow grip to occur on concrete massive block foundation material. Generator foundation. Generator foundation, that's very important point in this. Make sure you have to see generator foundation is massive block. First of all, we have to remember it's not ordinary concrete. It may be 1.5 meters or more, maybe 1.75 meters in some cases, and maybe more. But to keep in mind, it's not every baby's job. We have to be very considerate with such types of foundations, and we have to be sure about this. What we are going to do must be right and correct, cannot be taken for granted. After all, this is permanent job and this is machine foundation. We have to be very reliable. Our design should be reliable in construction as well as in designs. We have to construct this in very intellectual way, in a way that it's called quality product. It's very tolerable but non-tolerable. We should not show egoistic approach on such members in engineering. It's difficult job. You have to control its opening of sides or bulging. We have to control its dimensions, alignments, and we have to be very aggressive This job needs quality. This job needs quantity. This job needs skills of reinforcement fixing, skills of formwork, skill of fabrication of grooves volume, and this is therefore very significant one. Capability for isolation, arrangement, and also capacity of forgetting people once they do it and never remember them. So we have to make sure that reinforcement of generator block is placed in right locations in form of multi-layer steel on-site worked assembled meshes. It's not easy. It depends upon what sort of reinforcement design gives. It may be multi-layer design, multi-layer horizontally, and complexity in verticality, which may be different types of designs. Moreover, it's machine design, which is, you can say, a solution is required where no concrete should be without steel bars, means no crackings would be allowed. So sand can be higher size, can be lower size. In our consideration, steel may be very complicated. There may be hundreds of rings or struts in single or in one row, many rings. We have to understand design and use our minds to let people understand what is being said. So we understand what we do. Let me just take 2-3 minutes before we Make sure reinforcement of generator block is placed in right locations and form of multi-layer steel on site worked assembled meshes. Ensure that reinforcing bars are placed in line to design details whatsoever. This items pertain to massive block concrete. This item pertains to massive block concrete detailing, which requires attention of an you can say experienced engineer or pragmatic foreman who can personally attend to direct its installation, because it being a machine foundation designed based on foundation countering. Make sure that vertical forms are erected on all sides of proposed massive block. Make sure that vertical forms are erected on all sides of proposed massive block. Make sure that formwork is carried out in a good fixing arrangement. Make sure that all side supports are strong enough, rigid enough, so as not to permit either opening or movement of sides, and also to avoid bulging of sides. Remember that all massive block sides shall be provided with abutting concrete trenches or passing trenches just there for running electric cables within trenches, and where it moved or bulged sides shall not work, which work state could lead to considerable grinding of bulged areas to bring back concrete profile to true vertical. Make sure concrete covers are fixed correctly to all reinforcing bars. Check top alignment and plumbs so that formwork plan meets to requirements at bottom as well as top profiles, and for sure in middle locations. Check setting out for anchor bolts location for locating and fixing blockouts or grooves. Check blockouts truncated formworks as they are shown you in those grooves. It's a complicated item. It takes time to fabricate these blocks, but it is to be done. There are so many grooves and we have to install them. No other way, not only install them but to fix them. Check these blockouts forms are fixed in position, true position, and are truly vertical and well anchored so as not to move out of fixed position. Make sure about providing cathodic protection if it's required. In case of cathodic protection provisions, continuity test shall be required to be conducted, and activity of pouring and curing to be followed per concrete pour plan, and of course in steps pouring so as to avoid cold joints formations, and reinforcement specifics again same, that all bars, reinforcing bars must be clean and free from rust and dust. Sacrificial anode if fixed, if installed, you cannot use epoxy coating, and if electrical continuity check is done, this means we are going to use non-epoxy coated, or you can say plain bar, or you can say tar steel or whatever. Electrical continuity check is done in case it is required, and if cathodic protection is installed. Ensure touch-up paints if no cathodic protection is installed but epoxy or coated bars are used, in which case cathodic protection would not work. Alternative foundation works, continuation of same, that is continuation of same, that following operations are required. Following described operations are required for thick column with addition of provisions of pockets or grooves for blockouts. Alternator foundation is a thick concrete element, which means its minimum dimension in plan is at least 800 mm and height could be 2 to 3 meters or more depending on designs. Steel vertical reinforcing bars have already been fixed or were fixed at the time of raft RCC work. At this stage, horizontal reinforcing stirrups or links as well as all other bars in outer shape are to be placed in installed. Grooves are to be installed there, as I said. Formwork plates that must have been fabricated in yards are required to be brought to location and erected. Post steel reinforcement approval. Formwork of grooves must also be made available for installation. All sides of alternate foundations formwork shall be erected and fixed properly so as no side opens at time of concrete pour. All formwork checks to ensure position and verticality shall be conducted. Remember that cable trench shall pass adjacent to sides of alternator foundation concrete, which means vertical and side accuracy is required as it is required for massive block. Level line of concrete top shall be fixed on formwork inside and it's done in all concretes whatsoever. Grooves formwork shall be fixed and well anchored so that no movement occurs during concrete pouring. Approvals shall be obtained for formwork for purpose of concrete pour. Pour shall be conducted in layers not exceeding 400 mm thick each layer. Reinforcing bars, particular requirements same. Ensure reinforcing bars are clean and free from rust and dust. Sacrificial nodes is fixed if it's required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check tests shall be conducted if cathodic protection is required. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars and no cathodic protection is permitted on epoxy coated bars. So this is brief only, and these two sketches are very important in this for purpose of indication of where to do. This is also very important element. As you can see, this is very special type isolation treatment from machine to foundation. It is old technique, maybe different one now, but I think it would work. It will work as usual. We may find for something else that there's indeed no bad, so we can say that if I see Now, I should say something on this very special item. Just trying to find something here. It says large foundations, large powerful industrial machines are a significant source of dynamic excitation. This can cause damage to machine itself, affect nearby machinery and sensitive equipment, and even damage surrounding building structures. Moreover, people in immediate vicinity can be affected by transmitted vibrations or greatly disturbed by noise. So that's what it says, not very important here, I should say. It's the vibration isolation of machine foundation, active and passive. It says, let me just do something on this. Let us see how it works. You can come or turn and print it and see it works. It works fine. I'll take some time on this because this is important for us to understand. So let's do it. It says vibration isolation of machine foundations. I think you can see it now, right? Is it? Yes, you can see it now. Okay. You can see it now. Right? It's seen. All right. It's PDF now, and it is. I can save this also. It's better. I can save this. Vibration isolation of machine foundations. It is. I have to. It says that active and passive isolation. Vibration isolation of machine foundation. Unwanted vibrations, unwanted vibrations and shock impact occur in nearly all technical equipment and machinery. But elastic bedding with well-known materials which were called regofoam reliably prevent distribution of these vibration forces. Prevention of forces. Now, this is some company, maybe they are doing as per the size and supplied metal for vibratory isolation of machines, foundations for 20 years. What says is metal composed of rubber fibers. Name is Ragupool, I'm not interested in that. I'm saying is material is composed of rubber fibers, rubber granulates, rubber fibers, rubber granulates, SBR, NBR, and polyurethanes. And ragofoam is a mixed cell polyurethane foam. Mixed cell polyurethane, polyurethane is the epoxy. Then probably most important measure for reducing vibration impact of machinery in a building structure and surrounding is elastic decoupling of machine foundation. Elastic decoupling. We distinguish between active and passive vibration, that is isolation. In active isolation, the spread of vibration is reduced, and in passive isolation, sensitive equipment is protected against ambient vibration. So, reduction of vibration is active, says we distinguish in active vibration, active isolation, the spread of vibration is reduced, and in passive isolation, sensitive equipment is protected against ambient vibrations. Generally speaking, active isolation of source is preferred solution, as this measure can protect larger impact areas and thus several objects. These materials, when rigopole form, are subdivided into 8 or 12 load ranges each. As a consequence, they can cover a broad spectrum of vibration technology related applications. Thanks to rigidities of selected materials, settlement behavior is same as nearly all types. This provides expert consultants for vibration technology. Issues with two products grouped that are helpful to them in developing most economic and technically best solutions. Single degree of freedom system. Easiest example to describe vibrating system is a single degree of freedom system, SDF. You know this. An inert mass is on a rigid base. Inert mass is on a rigid base separated by an elastic element. So here is, you can say, mass. Here is rigid base, and there is a spring for isolation here. You can say damper is there. Force is here. Force excitation for vibration isolation of machines. Active isolation this is. Kinematic or auxiliary excitations for machine or vibration isolation of equipment. Passive isolation. So what it says, let's see. It says easiest example to describe vibrating system, single degree of freedom system. Inert mass is on a rigid base separated by an elastic element. Machine is equal to mass is decoupled from its ambient area by way of a spring and a damper. Only 1 degree of freedom is applied, and usually only vertical movement is considered. Special elastomeric, special elastomers, this as described by Gopal, and to perform simultaneously serve as spring and damper. Spring and damper. Spring, you have seen that, and damper is there. Now, model is quite useful in explaining basic issues of vibration, isolation, and is helpful in selecting suitable elastomers. Model can be applied to active as well as passive isolation jobs. A distinction is made between time-dependent force and kinematic excitation, auxiliary excitation of vibrator. Distinction between time-dependent force and kinematic excitation, auxiliary excitation of vibrator. Equation of motion of force excited vibrator is mx dot bx single dot cx is ft. Equation of motion of auxiliary excited is such. So we can see natural frequency. If a vibration capable system is made to vibrate and then left to its own devices, it vibrates with so-called natural frequency until it dies away. until it dies away, right? If a vibration capable system is made to vibrate and then left to its own devices, it vibrates with so-called natural frequency until it dies away. What dies away? Natural frequency. In machine foundation isolation, natural frequencies of the system can be deliberately influenced by varying its rigidity and inertial properties. Natural frequency is calculated as follows. You know this, what I'm just repeating. And that's Fn, Fo is equal to 1 over 2 pi into under root S over m. S is dynamic rigidity and m is vibrating mass. Inertial properties depend on the geometry and mass ratio of machine and intermediate foundations. Rigidity properties can be set to desired level with regopole and regoform elastomers. To achieve low bearing frequencies in one load range, thickness of elastomer must be increased. It's the fact that frequency progression of different types of regopole and regulation are similar in respective load range. Reasons are mainly as follows. Achieving high load bearing capacities requires a minimum rigidities of elastomers. Achieving high load bearing capacities requires minimum rigidities of elastomers. Considering greater mass and load bearing capacity, that is therefore required, and hence also greater rigidity. Above formula shows that similar bearing frequencies can be achieved again. Thus, lower bearing frequencies can be achieved by increasing dynamic mass. Lower bearing capacities frequencies can be achieved by increasing dynamic mass and by reducing rigidity of elastomer. Airborne sound insulation. Born sound insulation is different, but when it comes to machines, considering airborne insulation often doesn't suffice. This is illustrated by following. What it says: music box in illustration at top. Music box in illustration, top represents our machine. When clock mechanism is wound up, barrel begins to turn and 18 pins generate a soft melody. Due to a small geometric dimension of device, only a few of oscillations are transformed into airborne sound. Let us see what is this insertion loss. If it's meaningful, okay, otherwise discuss. You can say success of an elastic solution can be described using example of insertion loss or isolation efficiency factor. Insertion loss describes difference between application of force on in ambient area using rigid and elastic bedding. Is rigid and elastic. Isolation effect Isolation effect depends on ratio between natural frequency omega 0 and interfering frequency omega. Natural frequency should be below lowest interfacing frequency, low adjustment, softer elastomeric, and thus lower natural frequency, better isolation effects. Chart below shows isolation efficiency and insertion damping of material like pole vibration. To have all documents about materials. This may be found in our technical volume. This interfering frequency, and there is this is insulation effect of a spring mass system. Now dimensioning machine foundation isolation. This is an important one. Dimensioning vibration isolating measures is duty of expert consultant. Consultant is only person who can judge complex overall building dynamics. When planning elastic machine foundation isolation, special care must be taken that component resonances are avoided. Let's say when planning elastic machine foundation isolation, special care must be taken that component resonances are avoided. Component resonances are avoided. Attention should also be paid to place where equipment is installed. Simplified view of regarding machine as a single degree of freedom system is based on an ideal rigid placement of elastomer. When excitation masses are not very small compared to mass of foundation, it might be necessary to consider foundation impedance. For isolation to be effective, following important planning parameters must be taken into account. For isolation to be effective, following important planning parameters must be taken into account. For machines with harmonious excitation, such as building equipment, isolation effect is determined by ratio of interfering frequency and natural frequency of elastic bedding. Natural frequency, degree of isolation effect depends on dampening behavior of elastomer. So it is polyurethane foams and composite products. Polyurethane foam, polyurethane is kind of epoxy foam. Polyurethane foams and composite products made of rubber fibers, rubber granulates, this rubber fiber, SBR, MBR, and polyurethanes exhibit pronounced non-linear material behavior. Consequently, it is necessary to perform precise material tests. Typically, an attempt is made to generate supercritical bedding for machines. So we can say typically an attempt is made to generate supercritical batting for machine. This means that natural frequency is smaller than interfering frequency. To achieve a physical dampening effect, it's absolutely necessary that ratio is at least under 2. Under root 2. I think it should be 2, it's not right. It's absolutely necessary that ratio is at least under root 2. In point of fact, ratio should be at least 2 to 3. Higher selected ratio, higher isolation effect to be achieved. Ideally, planning measures for vibration isolation of machines with removal with these materials is conducted according to following pattern. हाँ खोल दिया calculation of characteristics compression partial load factor under machine foundation from dead weight of foundation block and wear weight of machine. It is says pattern is that following pattern: calculation of characteristic compression without partial load factors under machine foundation from dead weight of foundation block and dead weight of machine. Selection of suitable material taking maximum static permanent load into account. Selection of suitable type material taking maximum static permanent load into account. Considering crucial interfering frequencies of machine in case of active isolation, or consideration of crucial interfering frequencies of ambient area in case of passive isolation. Selection of natural frequency taking insertion loss isolation effect that can be achieved and ratio to interfering frequency into account. An absolute requirement, a ratio between natural frequency and interfering frequency that is of greater than under root 2. Installation of floating machine foundation taking points 1 to 4 into account. Machine foundation elevation now says step 1, you can say step 1. Step 1 is installing ragopole, vibration isolation, that is ragopole is material. Then step 2, setting up formwork for machine foundation. Setting up the exact cut to dimensions of foundation, then putting in a PE foil, putting in a polyethylene polyethylene foil with a minimum thickness of 0.2 mm. Filling with concrete and backfilling remaining space with concrete and smoothing everything at end. So steps, I think 5, 7, something wrong. Let me say. Step one is vibration isolation. Installing the pole vibration isolation. Number 2 is exact cut to dimension footing. Number 3 is number 2. Number 3 is setting up formwork for machine foundation, and number 4 is putting PE foil with minimum thickness. And number 5 is filling with concrete, and number 7 is backfilling remaining space with concrete and smoothing everything at end. And then say number 5, what happens? So nonsense it is that. In between there is a step that's putting in foundation reinforcement. Yes, that's right. And putting in concrete in that, and then it is allowing to harden and remove formwork. So this is gone. I think it should go. It's not that much. I was trying to take this now. Bilge insulating plates and air springs are extraordinarily effective for suppression of vibrations in foundations and base plates. Function of foundation is primarily to provide a rigid base for a machine, but also to increase moment of inertia. Foundation thus benefits vibration behavior of machine. Why disturbing me this? People are crazy, believe me. Foundation thus benefits vibration behavior of machine by reducing vibration amplitude. Still common understanding that a foundation just has to be big enough to prevent all vibration problems is just wrong. Because this man disturbed me, I just want to repeat this. There are some people crazy, so I just Repeat this. Function of foundation is primarily to provide a rigid base for a machine, but also to increase moment of inertia. Foundation thus benefits vibration behavior of machine by reducing vibration amplitude. By reducing vibration amplitude. This is main point. Reduction in vibration amplitude. Still, common understanding that a foundation just has to be big enough to prevent all vibration problems is just wrong. So here what's mean? Function is reduction of vibration means reduction of amplitude. Now in most cases it's helpful to take as many measurements as possible of machine and its future location. An on-site vibration analysis is a requirement for optimal vibration. Optimal vibration, can say in most cases it's helpful to take as many measurements as possible of machine and its future location. And on-site vibration analysis is a requirement for optimal vibration related calibrations. Isolation and separation. Isolation and what these people do, I don't know, yeah, really. It's not coming out. Isolation and separation machine the foundation from ground guarantees that machine can be operated without disturbance. Been collecting experience in the spatial area for many years and will be happy to undertake all works. Anyway, I'm not interested in that. Structure of isolated foundations. Now what it says? This is one is here, that is foundation, side wall, and the mineral fibers and cover plates lost formwork. This is two, so that one. Mineral fibers and cover plates is lost formwork, and foundation block. This is foundation block number 3. Number 4 is here, that is PVC film cover. Alright, then mineral fibers number 5, mineral fibers and cover plates lost formwork. Then this is insulation plate, and this 7 is foundation. Vibration isolated platform. Many applications require indirect vibration isolation due to requirements for isolation efficiency and level of consistency, or due to lack of rigidity. If a foundation isolation is not possible, that is because it is a floor installation, there is limited on-site space, place of installation has to be flexible, mobility, machine foundation, machinery mounting on a vibration isolated platform is a proven solution. Machinery mounted on an isolation platform, vibration isolation platform is a proven solution. Usually either welded steel structures or cast plates are used for that, depending on design of platform. Base of machine is additionally broadened and center of gravity is lowered due to additional mass or position of isolators. This significantly improves mechanical stability of the overall system. In this way, also machines with a high center of gravity and a small footprint can be mounted on very low frequency and therefore soft solutions. I read again. says that many applications require indirect vibration isolation due to requirements for isolation efficiency and level of consistency, or due to lack of rigidity. If a foundation isolation is not possible because it's a floor installation, there is limited on-site space. Place of installation has to be flexible. Machinery mounting on a vibration, isolated platform is a proven solution. Usually either welded steel structure or cast plates are used for that. Depending on design of platform, base of machine is additionally broadened and center of gravity is lowered due to additional mass or position of isolators. This significantly improves mechanical stability of overall system. This way also machines with a high center of gravity and a small footprint can be mounted on very low frequency and therefore soft isolation. Example of vibration isolated platforms. This is basic platform for lower building heights and machines with a high center of gravity. Platform for minimal building heights and machines with a very high center of gravity. Following pages, more sample application, foundation isolations. You can see this. Foundation isolation with air springs, rubber air springs, and this is with BL membrane air springs. With BL membrane air springs and level control download, Germany only. This is here, you can see, you saw that before. Development of low vibration foundation for 11 test environments. So what I said, and I think so we take it off now. कुछ नहीं, चलो इसको दिखा रहे हैं खलास। So I'll put this off now. Okay, खलास। So I just refer to certain publications on net regarding machine foundations and particularly vibration isolation, so that we clear to everyone why I have included this topic here. It's very much important from that viewpoint. And now we can say, I must say that then quality is a question mark here, it's an issue. But whatever we have to do, You have to understand every part. So we now go to this purpose of our machine foundation was very clear, and we're talking of generator foundations here. See, irrespective of designs, what design is, what machine is, everything is, we have to do basic study. We have to do study of everything. Basic study we have to do, we have to understand, to talk of. There are basic points somewhere. First consideration is that operational frequency of machine, and second consideration is natural frequency of machine soil system. These are two important points in machines where we consider. Machine foundation, you can say, is very important part, because machines are involved everywhere, vessels are involved everywhere. You can say vibrating machines are very much available on every plant's facilities. Devices पता नहीं कहाँ से आई यार. Well, I was talking about undue marriages, undue voices everywhere. अब बड़ी हरी यार भाग यहाँ से. कौन है यार ये? बंद है. जैसे उछलते हैं इस पे शेड पे. तंग करते हैं आगे खामा खां. बताइए. Oh my God, monkeys. My dear friends, sorry for that. Purpose of machine foundation we understand. Machine foundation is very important because this is very much engineering subject, and without this no factory can work, no industry can work, no plant can work. There are different types of machines and vessels. Machines, vibratory machines or stationary machines. Now we are considering generator foundation. This is vibrating machine. It requires heavy you can say dampening effect, higher dampening effect. Its operating frequencies are given by manufacturers in terms of altitude. And also there are different types of machines, like more higher than this, say compressors, turbine based machines, and all those where the voluminous quantity of vibrations are transferred to foundation soil. And it's not only foundation that is important here, it's foundation soil system. Generally 25% at least weight of system, foundation, soil is included, and soil machine work for machine foundations work together. So as far as our machine is concerned, we can say that operating frequency of machine is accounted for, and natural frequency is concerned. Foundation, weight, mass, and soil both combined together are considered. Both should not be equal. That is basic requirement to avoid resonance. We can say basic requirement avoid is that we cannot mix two, these, we cannot mix both. One should be different. That's basics. And there should be ratio of 2, possibly not more than that, not less than that, 1.5 set. Or resonance must be avoided, because resonance state is very dangerous. So we talk of heavy machines. Generally these are very heavy, so that foundations are also very heavy. In this case we have to understand, well, I'm not designing at this stage, not is my conception, but we have to go to procedures. Measure length and width of foundation should be considered in terms of size of machine. Size of machine, as much as size is taken, means area of foundation is taken, it gives better results, because formula is like that. We have to consider surroundings also, in addition to foundation, and also we have to consider foundation soil. How does it behave? What's properties of that, in addition to foundation properties? What's weight of foundation and what's weight of machine? Higher weight of foundation means higher natural frequency. In that case, comparatively, we'll find lesser operating frequency. But we have to see that these foundations cannot be installed above structural foundation of columns or walls. These have to go below. These have to go below level of structural foundations of vicinity, framing or something. It has to go below that. And if these don't go below that, this will impact, these machine foundations shall transfer its forces to those structural bases. That is not accepted. So basic requirement should be size of foundation is as bigger as possible practically. That affects values, that gives better product, better use, and operating frequency ratio and you can say natural frequency ratio have widened division. Now we can say it should be as below as possible, as lower as possible to structural foundations around. There should be adequate gap between walls, or you can say between walls and machine area, machine surface. There should be additional acceptable gaps for circulation, for maintenance, for operation, for everything, and for avoiding accidents. It must be there. We have to keep that in mind. These are major, physical requirements good soil, and if you don't have good soil, it's weak soil, we can improve that soil. Nothing wrong with that. We can keep distant from structural walls. We can take foundation lower than those walls so that impacts don't transfer to structures. We can keep adequate space around, and we can keep adequate space if there are coupling of machines. I mean to say, other pumps, others there in one hall there are many machines. So we can say that forming of machine, the layer location of machine can be decided, and there are set principles of this machine foundations. You may say that's the general requirement of machine foundation during design and detailing. This is, let us see just a quick look at this. Is very important point. A quick look at this. Let's have a quick look on this and see what it can give us. Following general requirements. Following general requirements of machine foundation shall be specified. Results checked prior to detailing foundations. Foundations should be able to carry superimposed loads without causing shear or crushing failure. Settlement should be within permissible limits. Combined center of gravity of machine and foundation should as far as possible be in same vertical line as center of gravity of base plane. No resonance should occur, hence natural frequency of foundation soil system should be either too large or too small compared to operating frequency of machine. For low speed machines, natural frequency should be high. Amplitude under service conditions should be within permissible limits which are prescribed by machine manufacturers. All rotating and reciprocating parts of machine should be so well balanced as to minimize unbalanced forces or moments. Where possible, foundation should be planned in such a manner as to permit a subsequent alteration of natural frequency by changing base area or mass of foundation as may be subsequent by require. For example, this is a machine here. You can see what I say. Let me see. General requirements of machine foundation for design and detailing. From practical point of view, following requirements should be fulfilled. Groundwater table should be as low as possible, and groundwater level deeper by at least 1/4 of width of foundation below base plane. This limits vibration propagation. Groundwater being a good conductor of vibration waves. This limits vibration propagation. Groundwater being a good conductor of vibration waves. Machine foundation should be separated from adjacent building components by means of expansion joints, and steam or hot air pipes embedded in foundation must be properly isolated. Foundation must be protected from machine oil by means of acid resisting coating or suitable chemical treatment. Machine foundation should be taken to a low then level of foundation of adjoining building structures, and these are major points. So you can say whatever we discuss, same thing is shown here as well. Means it's better to. So I don't think anything is required in this for saving purpose. There's nothing much important in this except this sketch, and this sketch is foundations is there. You can see these are place isolation basis on that is that. It's not much you can say of use. So I'm closing this file, and we can see that we got some here now. It's already time. We can have seen this. I'll just again review this sketch to you. These are grooves. This is massive block, and this is alternator block, and this is a raft, and here it is. Arrangement of isolation pads mounted on steel plate, and this alternator base, and that cycle is closes as well. Similarly, fabrication of lamina frame, structural frame. You can say kind of single thin structural frame, and this, and we can